Welcome, everybody. Welcome to SyPy Python for August. Super glad to see the turnout we've got. I know it's tough with the train strikes and just going into the city in general and all that kind of fun stuff. So we've got some standard housekeeping. Who's first SyPy here tonight? Awesome. Welcome, welcome. Who's been here at least once before? Awesome. Who's been here more than 5 times? There we go. Awesome. I'd love to see the mix. Welcome the new, welcome the not new. Standard stuff. Bathrooms are down that hallway, hang a left, male and female there. We have a job board. If you're looking for a job or you're hiring, hiring for Python, non-Python, DevOps, all sorts of stuff. We have a really big mix of people here, so there's always something for everybody. All of our stuff is on meetup.com. That's generally where we post all of our updates. We've also got a Slack. That's good if you need to contact any of the organizers directly in a very timely fashion. Otherwise, meetup messages are fine. We're always looking for new speakers. SyPy Python is a really welcoming and awesome place to give your first talk. And if you've given a talk before, give another one. We do long form talks, like we've got our 2 talks tonight. And we're also bringing back lightning talks for next month. Lightning talks are a super awesome way to get into talking. 5 minutes, 10 minutes. You found something cool in Python? Come and show us. You found something terrible in Python? Come and show us. You got 5 minutes on why you should never use Python again? Come and show us. Make sure it's got like a nice message at the end. Still a Python. We've got a website, sypy.org, which is our basic address, meetup, stuff like that. If you're interested in helping organize, send us a message on Meetup. We're always looking for people to help, grab new members, help organize, help on the nights, all that kind of stuff. Strict no harassment policy, as per standard. Meetup has a very good no harassment policy, all that kind of standard stuff. If you have any issues, I'm talking to myself. I'm Sean. Also, hello, I'm Sean. Our other hosts, we've got Anthony, and then I believe Rachel's downstairs. And Chewy occasionally. You may know him from the Golang meetup. Or they still use that? Who still uses Go? It's an indoor venue. If you're comfortable wearing a mask, you can always wear a mask. There's no problem with that. And as always, we are super thankful to Iress for hosting us. They've been hosting us for 3 years, 4 years, a long time. Pizza comes every time. The beer comes every time. Always. Do you want to give a little shout out?
Yeah, I have got guys. I'm going to just for the context. Thanks for coming. Yeah, thanks Sean for asking how many people were even new. I was going to do that. It usually steals my line. So yeah, thanks for coming. And maybe I'll change that question to how many people have heard of Iress before? I mean, you people have never seen you. You've heard of Iress? Oh, fantastic! Wow. Oh, Michael. How many have never heard of Iress? Oh, fantastic. Do you know what we do? No, even I don't know what we do, but so we do financial planning software, trade software, things like that. So if you have a financial planner in Australia, there's probably a huge chance that they're using our software to give you advice on your financial needs. If you're in the UK, most of UK's mortgage goes through our systems. So companies across UK, Canada, South Africa, I mean, all Australian states, including New Zealand, and Singapore, everywhere. So we are everywhere, and it's a really good company. And I was just telling someone when they felt a bit jealous, I think we have a whiskey club. I usually run it. Next week, Iress is sponsoring a whiskey tasting for the staff. So it's a cool way to get people. So I'm just advertising, by the way. And we are looking for people. We are looking for front-end developers, full stack, AWS, everything. So if you're interested, please put your name down there. If you don't want to put it down there, just contact one of us and that'll be great. Thank you.
Alrighty, so for tonight's schedule, we've got 2 speakers. What we normally do is have our first speaker, we'll have a little chat while the second speaker gets set up, and then our second speaker of the night. So our first speaker, is our lovely Jonathan Hodges. He's one of my coworkers, a platform engineer at 10x Banking down here in lovely Barangaroo. He's been talking about buying time with Boto3. The Boto3 AWS SDK is a simple yet powerful tool to extend AWS functionality with Python. In this talk, he'll explore what Boto3 is, how to use it, and examine a use case where 10x Banking platform engineering team leveraged Boto3 to cut client environment provisioning time in half. You're welcome.
Thank you. Everybody hear me okay? Just the volume, or just good in the back? All right, awesome. As Sean said, my name is Jonathan Hodges, and yeah, today we'll be talking about buying time with Boto3. Really quick agenda walkthrough. I'll do some introduction, go through what's the deal with Boto3 anyway, what it is, why use it, how it works, and what shouldn't you do with Boto3, and then close it off with a case study. First of all, the introductions. Yeah, again, my name is Jonathan Hodges. I've been in tech for about 10 years now. I started off in desktop support role and then moved into VMware and Windows sysadmin role, working with on-prem hardware. From there, moved into a managed service provider and saw the light with AWS, became a cloud consultant, and then moved into 10x Banking as an SRE, where we've now transitioned from our SRE titles to platform engineering. About 10x Banking itself. So 10x's goal is to be the global banking operating system of choice and enable banks to deliver products to market 10 times faster at 10 times lower the cost to serve, and reliably underpinning the service of 1 billion banking customers. Do that through their super core platform, which is a flexible microservice-based architecture, providing APIs, adapters, and accelerators to help transform at a pace or rapidly launch into new markets and segments. But today, I'm not really talking about super core. I'm going to be talking about the underlying software that we built under the platform engineering team that enables our future teams to build their microservices. So about platform engineering at 10x, our platform engineering team aligns with the definition found in team topologies by Matthew Skelton and Manuel Hayes. They define it as the purpose of a platform team is to enable streamlined teams to deliver work with substantial autonomy. The platform team provides internal services to reduce cognitive load that would be required for streamlined teams to develop these underlying services. So that's where we find ourselves now with the team. We have actually the vast majority of my team here tonight as well. Shout out for this. All right, so on to Boto3. So what is the deal with Boto3? If you're not familiar with it, this is the Amazon Web Services software development toolkit for Python, more commonly referred to as Boto3. It's used to create, configure, and manage AWS services, such as EC2 or S3. It provides an object-oriented API through the resource method, as well as low-level access through a client method to AWS services and APIs. If you are familiar with the AWS CLI, or the command line interface, the low-level client, the Boto3 client session, behaves in a very similar fashion. However, it is intended for use within a Python runtime instead of by a human user. Boto3 also provides resource sessions, which return a high-level object-oriented instance, which contains identifiers, attributes, actions, references, sub-resources, and collectors. AWS maintains and provides fantastic documentation that includes usage guides of all the supported services, including the required parameters, expected responses, and built-in exceptions. You can just search Boto3 on any search engine of choice. You're going to get that documentation pretty straightforward. And this is just a snippet of what you'd see in one of the methods available, how to provide that instructions. Why would you use Boto3? Well, first, Python would need to be your language of choice, which everybody is here tonight. I assume if it's not your language of choice, it's at least in your the top of your list. And you're looking to perform operations in AWS programmatically. This could be for anything from extending AWS functionality that's just not available out of the box. You have a lot of AWS services that have some built-in automation, but there's also ones that come with a lot of opinion. And if you don't, your desired use case doesn't actually match perfect with that AWS opinion, you might need to write something yourself. And you can do that with Boto3. If you're looking to create a system that's going to use event-driven architecture, you can easily perform operations on those events using that Boto3 library as well. And you can integrate your internal and external applications with your AWS environment. One of the projects that I worked at a previous employer, we actually took a service, I don't know if anyone's familiar here with Trend Micro's Cloud Conformity. And what we did was with any new account that was provisioned inside their organization, that would then invoke a Lambda, which would call the Cloud Conformity backend, enroll their account in Cloud Conformity along with a policy set, ensuring that as soon as that account came online, they were getting reports on the compliance of that new account. Some of the benefits of using that AWS maintained SDK, reduced development time. AWS releases new features and functionality to this library faster than they do almost any other one. And you don't have to worry about building out any of the retries or exception handling that all come right out of the box with the Boto3 library. And then you have that increased reliability and all of that. This is all built by AWS. You don't have to have any developers working on an API interface. How to use it? Well, there's only a few prerequisites to using it. You need to have an AWS account. You can't really start from scratch with Boto3. You need to have that account, credentials in that account, and then simply installing and importing it. So what I wanted to do, I find the best way to demonstrate how to use something is to have a scenario and then kind of walk through how to solve out a use case with it. So the scenario that we will go with today is that we have a disaster recovery audit that has revealed there's a number of EC2 instances that don't have snapshots of their EBS volumes. And we've been tasked with creating some automation to ensure that all those EC2 instances have snapshots. So for that, I'm going to switch over now to my IDE. So just bear with me a moment here, and I'll step through some stages as to how we might do this. So, of course not. Close down. Just for 1 moment. So we know that we need to find our instances, and we look through the list of methods available within the EC2 client. We can see, we get down far enough here. Yeah, we have described instances. Oh, sorry. And everybody see this okay? Bigger. How's that? Any better? Okay. Better? Okay. All right. Oh. Drop down. Go back up. On top of this. All right. So here we are within the Boto3 documentation. Okay. So where were we? All right. So first thing we need to do is find our instances. So we have here a very handy describe instances method that we can call. If we come down to our request syntax, It describes the different arguments or parameters that we can pass into this. And if we were to come across one that's required, it would be detailed here. I'm not going to go through all of them right now, but spoiler, there's no required parameters. So we can just run this. So here, if you look at the code, we'll see. Yeah, absolutely.
Let's take a second. People in the Zoom can see it. Yep.
And that is the question.
There we go. Don't say it. I think that's what you do, isn't it?
That's just
Ah, interesting. Okay.
yeah. Okay. Awesome. So here we are. We're importing our Boto3 library. We're going to instantiate a client with EWC service. We're going to call our described instances, and then just to see what we actually get back. Let's see what comes. So we get quite a massive data set back. That's not really that usable. But there is a lot of information in there, and maybe we'll find what we're looking for. So I can go back to my documentation, go down to my, actually right down to response syntax. And if I have a look through here, I can take a look at what actual values and data structures there the AWS is going to return to me. I can look in here and I can see, okay, well, there's something called instances, there's instance IDs. That's probably what I'm going to be looking for and to find the instances that I have running. So I go to the next step. Reservations. This is one other little potential gotcha sometimes people run into with the documentation. Some of the names aren't particularly descriptive as to what it actually means. Reservations here is a list of dictionaries, and it can be a grouping of instances that are launched at one time. So it is easy to miss that you need to iterate through this, but you will need to iterate through the reservations and then through the instances, which is its own list of dictionaries. So here what we're doing is we're going to get the reservations list, and then we'll iterate through the instances and then collect the instance ID. So let's see what we get back from this one. It's looking like something I can start working with. I've got my instance IDs, but I don't really know anything about them other than that they exist or are currently recorded within my account. Instances can be in the two different states. They can be running, they can be terminated, they can be paused. My initial ask was to just collect running instances. So I do need to filter down to the state. So let's have a look at what we actually have. What I'm doing here is just collecting the instance ID, collecting the state as well, and then outputting them combined print statement. I can see here I've got a bunch of running instances. I do have a terminated instance, so I do need to filter that out. And a few different ways that I can do that. I could, similar to what I've done before, go through that data set and put in a condition and exclude any of them that are not in a running state. However, there is another argument available within the described instances. Go back up to that. So filters. And in filters, I can provide a variety of different options on what it is I want to filter on, or what AWS to filter the response on for me. I can have a scroll down and look at that instance state name and the available states that I have from the people that are running and when running. So here I have my filter now included as a parameter in my that call. And now I need to get the volumes as well. So if I go back to my response, I can see down under block device mappings that this is where EBS volume information can be found. Again, it's a list of dictionaries, so I need to iterate through this list. Then select each EBS and collect the volume of these out of them, which is what I'm doing here. And I'm creating a set because I want this to be immutable. So I'm creating a set where I'll add these volume IDs to them. I'll see what now I get back. All right, so now I've got one step closer to what I was looking for. I've now just got the volume IDs of the instances that are running. Now I knew that the parameter, the instruction that we received is that there was some that didn't have snapshots. So I'll need to go a little bit deeper and now start finding out which ones of these volumes have snapshots. So this is with another method available in the EC2 client called describe snapshots. And using that same filter parameter and providing it the volume ID, it does only accept lists. So I just have to convert my set to a list and pass that in as these acceptable values and see now what I get back. So none of my volumes have snapshots. The audit was correct. I do have instances that need snapshots. So at least I know I can validate now that there's action that's required. So we'll go one step further. What I would like to do now is determine in the event, say there was some that had snapshots, I need a way to compare what has snapshots and what doesn't, as I don't want to potentially be creating excessive snapshots. So here what I'll do is do a comparison of those snapshots in the response that it comes back from that. Again, if I go to documentation, I can go to snapshots. And see what kind of information it comes back. So it will provide me with the volume ID, so I can start to do cross-referencing there and determine which volume is snapshotted. So that's what I'm going to take advantage of. I'll iterate through the responses. If there were any, we iterate through the responses. And then remove any of the volumes that have snapshots from the list that I created, and then have a look and see of the volumes which ones actually need snapshots, and give me a count as to how many volumes require them. So I can see I have 78 volumes that require snapshots, and then I get my list of volumes as well that require them. The last step that I have then from there is to create snapshots themselves. Luckily enough, we have a create snapshot method that I can call, where all I need to do is pass in the volume I need to create that snapshot. There's which is funnily enough the only required input. There is a create snapshots plural method that's available. However, what that does is create snapshots for every volume that's attached to an instance. So the way that so far we've gone through in order to identify the volumes that need it, There may be a situation where you have some volumes on an instance that have snapshots, some that don't. And we would need to pass over each instance ID. We would do that one. If we're going volume by volume, we just make a snapshot method and see what we get. Now, this is a live account that I'm working with, by the way. So I have actually, for safety's sake, I do have a dry run that I put in place for the create snapshot method. But I did also want to demonstrate one other thing that I was speaking of before, and that is the exception handling that's built in with Boto3. In order to take advantage of that, you do have to import one more library, the Boto3, and that's where all of the exceptions are defined. So here I've wrapped my create snapshot call and a try except, and I'm capturing the exception that when you execute a dry run, it will actually throw an exception. So I'm capturing that, checking to see if the error code is that it is a dry run application. And I'm only one time printing out the actual error message as it would iterate through every single document with the snapshot. And I get 78 of these messages, and I'm just breaking out my loop. And in the case that it's a different type of error, just to break an exception as usual. The nice thing about the dry run operation as well is that it does tell you whether or not it would succeed. So here we have our request would have succeeded, but dry run flag is set. So we can have confidence that if we were to turn that dry run to false or remove it from our input parameters, those snapshots would start to be created. All right, we'll jump back to the presentation here then for a quick little rundown of what we accomplished. So using Boto3, we completed our assigned task. We identified all of the EC2 instances that were in a running state. We collected the volume IDs of all of the attached instances. We determined whether or not they had snapshots, and then created snapshots or did a dry run of creating snapshots of any of the ones that required it. From there, it can easily be extended to do comparisons on the start time response. So if you have a say snapshot policy every 24 hours, you can easily do a comparison there in order to determine snapshots needed, and then wrap that inside of a Lambda function with a scheduled CloudWatch rule, which is for all sakes and purposes a cron job that will then run based on your snapshotting policies. All right. When shouldn't it be used? There's really not a lot of time when you shouldn't. However, it is not a replacement for infrastructure as code. You can use Boto3 to spin up all of your EC2 infrastructure if you want to, but there's no state management, and it is an imperative language. So if you're looking for something that's Python based in order to manage or possibly be a replacement, have a look at this, the cloud development kit, not the software development kit, the CDK. And Boto3 should not be used to manipulate infrastructure that you provision with your infrastructure as code, as that will create direct cornerstones. All right, so that's it for Boto3 itself. I'll talk a little bit about what we've done on the platform team to leverage that and accomplish the challenge that was set up for us. So before we get into that, I just wanted to talk a bit on some of our concepts at 10x. We have a loosely defined relationship between it's not really a strict hierarchy. We do flatten this out. However, there is a certain amount of, there is a relationship that exists between these levels where we'll have one client, a client can have multiple environments. An environment at this point has 3 AWS accounts. Each one of those accounts has unique infrastructure, and then our supercore services deploy across all of those accounts, and depending on which services are operating which particular function. So the context. Last year, 2021, the platform team was tasked with building a new environment for a net new client. And at the time, the documentation that we had grown slightly out of date, as there was a number of new infrastructure that had been rolled out and new development that had happened that had not yet made it into the documentation, as we had created a brand new environment in some time at that point. So the team set out to complete the build through a code analysis and plenty of trial and error. During earlier development and deployment, many of the processes, for the sake of expediency, were required manual executions of Terraform, followed then by the collection of values and the outputs of the Terraform to then be committed as config for input for the next set of modules that would layer on top. Kind of an ideal problem case for automation, as you're just doing things in stages, collecting outputs, using other buttons. So that we were able to successfully deliver that environment, we looked at the estimated build time of two engineers for 10 weeks, and looked at that and said that's an unsustainable linear scaling model. We need to do better than this. And before we start signing on even more clients, and our team has to explode and scale just to start building up the environments. So we looked to build a solution, but we had a number of constraints that we had to work with as well. We were supporting existing live environments. This included incident response, support requests, feature requests. We were not working in a just in a development, we were live. There was also multiple products being developed by the team. So even though we had a team of 12, I wanted about 2 to 3 engineers that could be made available at any one time. And certain stages of the actual process was required actions by teams in other geographies in other time zones. And as well, while we were working on this, we had more environments that were required and expected to be delivered during the time frame that we thought we needed to, or during the development window that we estimated to deliver to the automation. So we needed to build some functional chunks of automation that would reduce our time to deliver these environments and buy ourselves the time we needed in order to finish an end-to-end solution. We launched a project we called Genesis, and let's see what this a number of design principles that we took to heart when we started solutioning, that we wanted an event-driven architecture. Needed to be idempotent, the stages needed to be loosely coupled, it needed to be scalable, secure, it wanted to be entirely serverless and easily supportable. So the Python stack that we went with is at the very top at our interface, we leveraged the Fast API in order to provide an API framework, and Mangum in order to provide an asynchronous server gateway interface adapter for running it on Lambda functions. Use PyJWT for JSON web token handling, Pedantic for data validation, PyTest for unit testing, Moto for AWS service mocking, and then Boto3 for all of our service resource management in AWS. For AWS orchestration and compute, we use AWS step functions. This is a fantastic orchestration service that you can control and direct actions across distributed resources into most of AWS at this point, and has a wonderful 1-year timeout. That's a timeout. AWS Lambda for most of our serverless compute. However, it is limited to, at this point, still limited to 15 minutes, but that's better than it was. And then AWS code build in order to take advantage of that 8-hour timeout, which is an ideal serverless runtime for running Terraform tasks that can occasionally go longer than 15 minutes, like deleting a VPC Lambda. If you've ever had that fun in Terraform, that is a nice long wait. So in order to deliver this in chunks, the first thing that we took on was creating an account itself. And this is actually the visualization that step functions provide once you do define one in AWS. It does a nice auto-generated diagram for you in order to track and follow along its progress. If you have an execution that's happening, very nice, gets watched nice and pretty and green all the way down, or if something goes wrong, you see it go red. And you can, from the console itself, you can collect information as to what went wrong, if you so desire. Or of course, you can use Boto3, which we do, in order to collect that information automatically and present it elsewhere. So our first chunk was the create account, which just creates the account using the AWS Organizations API. This is a very handy way to create one, as long as you have the right features enabled, you instantly get roles within that account that allow you to assume roles into it and start configuring and deploying resources. And of course, it waits for the account to be in a ready state before anything else happens, because it does take a couple of minutes for the account to be ready for any other type of follow-on activities. That one's pretty. Yeah, so the configure account, the next chunk that we looked at, create account was, that shaved off maybe a couple hours per account, but we weren't really getting a whole lot of time savings there. Once we had the configure account workflow solved, though, now we were taking a couple of days off of our provisioning time. This is decoupled from the creation, as we knew that we might redefine or have multiple types of accounts that we want to have different configurations for. Even though we have a picture of what an account looks like right now, we didn't want to tightly couple it and have to re-engineer something if we have another model that might come out down the line. And this simply bootstraps the account for Terraform using CloudFormation, deletes a lot of the unused default resources in the account. We seed a bunch of our parameters into there, so all of our follow-on resources can simply collect their parameters from SSM parameter store. Configures a few simple guardrails, manages the OU placement within the AWS organization. This is if you have a sensible OU structure and you have SCPs in place, service control policies in place on those organizational units, moving something from a less controlled OU during the provisioning stage can then be moved into a more production with all of the guardrails in place, that instantly preventing any of the unwanted activities in there that you might need to have during the configuration stage. We bootstrap our SSO and some of our CI/CD prerequisites, and then notify our subscribers when the account is ready. So this started to shave off days, but we were looking at the original concept. We do have at least 3 accounts that we need to create, because we started looking at how do we automate an entire environment. So what we started with is the idea that we're going to nest these step functions. And one of the really nice features of them is there is a token that you can generate and pass on to your nested step function, or really any other service it is that you want to integrate with, that you have an asynchronous activity. That token can get passed along, and then depending on the business logic of what is being executed, it can call back to this step function and report a success or failure. So what we've done is, in parallel, called the create account, the original create account one that I showed, provided a token to that step function, which then passes it along to the configuration account. And then when the account's ready, comes back, reports back to the environment factory, the account all good to go. You can continue on with the next steps. It then starts to configure the code build runtime in order to run some of the Terraform templates to deploy further resources. And now we're tying it into some of our other tooling as well, creating our CI/CD pipelines in Concourse. In order to ensure that if someone were to invoke this twice with the same parameters, we created our own state lock as well, which we've integrated both in the happy path as well as within our error handling. I'll show you in a second here. Actually, right now. So one of the challenges that we came across with this was, how do we bubble up errors? We have this asynchronous execution. How do we bubble up the errors from 2 nested deep step functions into to the either the requester or to our teams, so that we get notified that something's gone wrong? The way that we solve for that is that when the account factory layer has a failure, this it notifies a Lambda function tied into event bridge and event bridge rule, CloudWatch event rule, same thing, they just rebranded it, which triggers the Lambda, and that enriches the error function. The error message that comes from the step function is a little bit, it's not as helpful as it could be. So our Lambda then collects more information from the other Lambda functions that were being called, as well as the step function, passes that on to an SNS topic, which triggers a environment factory failure, which then uses that token again that we generated to pass the failure message onto the environment factory, include the failure message from the account factory that passes its way down again as well, releases the state log because now the runtime has failed, and then updates our records in DynamoDB for the status, and then messages us on Slack for the notification. So what we've wound up with, just a basic summary here of what we have presently. Within our tooling account, where we stored all of our different Genesis components, builds the AWS accounts, creates the records for the client within our DynamoDB table, creates the CD pipelines within Concourse, which then auto executes and starts deploying our infrastructure into those accounts. And since we're using Azure as our SSO IDP, we also have a registration app that function that registers that the new accounts for us. So we've got two so far. We have our clients automated, our environments are automated, our accounts are automated. Our infrastructure is getting there. A lot of our modules have to be refactored in order to automatically apply, as the configuration was distributed across a few different places. So that work is in progress. We've also integrated it with our in-house platform UI, which we branded as the Tenants Console, which is one of those products I was saying that our team was working on as well. And we're currently testing environment teardown. So if we can get to that, then we can start having some ephemeral environments, which will be development fantastic faster. We're also developing further integrations with a lot of our supporting applications, that's Slack, Jira, Elastic Data Page, New Relic, etc. And where we're at now for our time to deliver, we're now down to a single engineer can get to this point within 3 weeks. Where before I was saying we were looking at 2 engineers for 10 weeks. So we're really happy where we've got to already for now, but we're still working towards getting a fully functioning environment to click at a button. And this is the button that it's going to be. This is the UI that the team has developed, where once they pass in just the required parameters, they should be able to hit create and get essentially a fully functional bank in 3 hours. Yeah. That's all I have today, but I just wanted to say a lot of the work that's on here has been done by actually a lot of the team that's here tonight. I've the privilege to tell the story. However, my contribution is very small, but very proud of the progress that the team has made for such a short period of time. So thank you very much. And yeah.
All right, thank you very much, Jonathan. That's time for maybe one question. That's one right here.
Thanks for that. Question about the environment teardown. Where do you store the dependency graph to tear it down in the right order?
Is this back on? Yeah, back on. Okay. I'm actually not the right person to answer that question for you. I would love to be able to. I don't know if I can call him out right now if Will knows the answer to that question. As the engineer who is directly working on that is not here tonight, but Will does work closely with him, so I don't.